Hi everybody, I hope this video finds you well. Today we're going to be introducing the concept of conditional analysis. Now, in the previous set of videos, we had just worked our way through talking about correlation and regression. Correlation and regression was the idea of trying to understand and model and use the relationship between two quantitative variables. Now we're going to change gears and have a similar goal, but slightly different, in that we're going to be trying to understand the relationship between two categorical variables. So the gear that we're changing here is switching from quantitative variables into categorical ones. But we're still going to be trying to understand relationships between variables. Now, just like we did with correlation and regression, we first needed to understand the way that this data will be presented to us. So the first thing we're going to talk about is a little bit of a definition here. So we got to talk about what is a two-way table. So a two-way table is simply a way of showing a sample of individuals that have been classified according to two categorical variables. So we've got an example below that shows us what a two-way table looks like. And for the entirety of this video, this example will be the one that we'll be following as we learn all the different pieces that we can use in this analysis. So our example for this video is going to be that we take a sample of voters from a small town and we record their gender, so whether or not they were male or female, as well as their political affiliation. And we allow them to have the political affiliations of Democrat, Republican, and other. And of course, that other category is a big catch-all. Those could be independents, they could be Green Party members, libertarians, whatever, right? We're just putting them into that other category. And so we get this data here. And this table that you guys are seeing right here, this is what a two-way table is, right? It shows how our sample of voters were classified according to their gender here and their political affiliation there. So this is a two-way table. This is pretty nice as a two-way table. There are a couple things that we might want to add. One thing that we should always add on whenever we see a two-way table are the totals. So let's just make a little note of that at the bottom here. Note, always include totals for a two-way table. So if you guys are ever working on the practice or on a quiz or an exam or something and you see one of these two-way tables, make sure you go ahead and get the totals right away. So let's go ahead and get the row totals first. So we'll take 21 plus 32 plus 49, and looks like we should get 102 here. And then 71 plus 33 plus 98, looks like we should get 202 there. Then we can do the column totals, 21 and 71, and we can get 92 right there. 32 and 33, we should get 65, and then 49 and 98, we should get 147. We can also include one more total, which is the total of these row totals or the total of these column totals. Now, no matter which way you decide to do it, you've got to get the same value here. So if you take 102 plus 202, you should get 304. And if you do 92 plus 65 plus 147, you also get 304. So this value right here, we would write as 304. Now, let's actually talk about what some of these values mean. Now, let's actually begin by talking about this guy right here. That 304 is something that we've actually seen before. And it's our table total, but this is also our sample size. This is how many individuals we had in our overall sample. So we had 304 people in our sample, and then we classified those 304 people into their gender and their political affiliation. So let's talk about what some of these other values mean, right? Let's think about what this 102 right here would mean, right? That was the row total for males. This would mean that we had 102 males in our sample. So what this means is that in our sample, we had 102 males, regardless of their affiliation. So we had 102 males in our sample overall. All right, let's get a nice different color here. Let's think about what this 92 represents. Well, this 92 here would mean that we had 92 Democrats in our sample. So we had 92 Democrats if we sort of forget about whether or not they were male or female. We just had 92 people that identified as Democrats. Finally, what does sort of one of the inside values mean? I don't know, let's grab this purple color here, right? Let's just say this guy right there, right? What does that 33 mean? Well, that 33 would mean there were 33 individuals who were female and identified as Republican. So these inside values, right, those represent individuals that had both those traits. So there were 33 people in our sample who were both female and identified as a Republican. So that sort of helps you guys just understand what these components mean, right? The inside of the table, these values in here, these represent individuals that have both of those traits. The row and column totals represent people who just have one trait, males here or just Democrats there. And the overall, or the table total, that is your sample size. And so this is just something handy to sort of understand what a two-way table is showing you. Now, two-way tables are nice, but as we sort of know, a lot of times as numbers get larger, people start to struggle with like number sense and things like that. So we're going to see a way of sort of changing from the frequencies that we're seeing here into relative frequencies. So let's talk about that on the next page here. All right, so we're going to give another definition here, a marginal distribution. So we're defining this idea of a marginal distribution. A marginal distribution shows a sample of individuals classified by two categorical variables, but written as percentages of the entire sample. So in other words, it's basically a relative frequency version of a two-way table. And it is created by dividing every element in the two-way table by the sample size, the table total. So let's see how to build that. We have our table right here. I'm just going to quickly go back and fill in the sort of the totals that we had gotten. We'd gotten that this guy here was 102. This guy was 202. This guy was 92. This was 65. And this was 147. And this was 304. So we had done that on the other page. All right, so let's go ahead and build this marginal distribution. So all you need to do to build that marginal distribution is divide by the sample size. So we're going to redraw or rewrite our table, but divide every element by that sample size. So we'll rewrite it. I'll start abbreviating. So we'll just do male, female like that, and Democrat, Republican, and other. Okay, so we'll just make our nice little table there. And okay, so how do you get this sort of first value right there? Well, you'll take what was originally there, 21, and divide by the sample size, 304. 21 divided by 304 should give you a decimal. You could report it as a decimal or maybe more easily as a percentage. So you should get 6.9% there once you put it into a percentage form. All right, next one would be 32 divided by 304. So we should get 10.5%. And then 49 divided by 304, and we can get 16.1%. Now, we could go ahead and do 102 divided by 304 to get this sort of value right here. Or we could, of course, just add these percentages, just like we added these frequencies to get that frequency right there. Either way will work. I'll just do the division. 102 divided by 304 should give you 33.6%. And if you go through, you'll see that if you added them, you get a slightly different value just by a little bit of rounding. It looks like you'll get 33.5%, but again, that's just rounding issues, not actually anything being off. All right, so let's fill in the other pieces. Now 71 divided by 304. So this gives us 23.4%. Then 33 divided by 304. Looks like we get 10.9%. And then 98 divided by 304. Looks like we get 32.2%. Then we can take our 202 and divide by 304. And looks like we should get 66.4%. Then we can fill in those column totals. 92 divided by 304. we can see that is 30.3%. And 65 divided by 304, we should get 21.4%. And finally, 147 divided by 304, we should get 48.4%. Okay, now of course, if we went ahead and looked at that sort of table total now, that would be 100% there, because we're writing everything as a percentage of the overall sample. So how would you sort of interpret these different values? Well, we can pull some of these out here, right? This right here, that 23.4, what that would mean is that 23.4% of our sample were females who identified as Democrats. So in other words, what we're sort of saying there is close to a quarter of our entire sample were females who said that they were Democrats. Okay. If we pull out one of these sort of values here, right, like this 66.4, this would tell us that 66.4% of our sample were females. So you'll notice that there were many more females than males here, right? We knew that there were 202 versus 102, and we know that that actually means that females made up 66.4% of our sample. And finally, if we do sort of one other one, maybe, this guy here, that 48.4, that would tell us that 48.4% of our sample identified, right, as other, meaning that they did not identify as Democrat or Republican. So in other words, close to 50% of our sample, forgetting about their gender, reported that they did not identify as Democrat or Republican. They were identified as something else. Okay, so the marginal distribution that we built right here, very easy. You just divide by the sample size to get all these sort of things there. It's interesting because, again, it is helpful to people to give them a sort of sense of the size and sort of proportion, because people do struggle with that when they just see a bunch of raw numbers. But the marginal distribution by itself doesn't really help us with that overall goal that we gave at the beginning, which was to understand the relationship between the variables. In this case, the relationship we're sort of interested in is gender at all related to political affiliation? So this marginal distribution, while it's sort of a nice way of displaying or summarizing the data, doesn't really help us with our goal of understanding the relationship. So we've got one more thing to sort of introduce here. So let's go ahead and take a look at that. We're going to define now what's called a conditional distribution. And a conditional distribution really will help us achieve our goal of understanding the relationship here. So a conditional distribution, that's what we're defining here. A conditional distribution shows how one categorical variable is distributed amongst one category of another categorical variable. So it basically shows how one variable is distributed inside the other one. It is found by dividing all the elements by either their row or column totals, depending on the location of the explanatory variable. So notice that, again, it's going to be based on sort of doing a division, but instead of doing the table totals, you'll be doing the row or column totals. And you choose whether or not you're going to use the row or column totals based upon which variable you think is explanatory. Now, we have a little note here, so you should note that because you could use either variable as the explanatory, there are always two possible conditional distributions. But generally, since only one variable will make sense as the explanatory, only one conditional distribution will make sense. So we've got our data here. Again, I'm just going to fill back in those totals that we had. I think this was 92, 65, 147, and then we also had 102 and 202 here, right? And then we also had that this guy was 304. So we're going to build two conditional distributions here because there's two possible ones, and I want to show you guys both of them. But we're going to build the first one, the one that sort of makes more sense. If we think about these two variables, gender and political affiliation, we would think that if there is a relationship, gender should be the explanatory and the political affiliation should be the response. It doesn't really make a lot of sense to say that your political affiliation influences your gender, but the other way around does make sense. So let's go ahead and build the conditional based on gender. So we're going to build that conditional first. All right, now gender was in the rows. So each gender was in its own individual row. So to do this, we're going to divide by the row totals. Okay, so we're going to recreate our chart: male, female, Democrat, Republican, other. Okay, there's our nice little chart there. And to fill in these values, what we're going to do is we're going to take each value inside the chart and divide by its corresponding row total. So for these values here, we will be dividing by 102. And then for these three values here, we'll be dividing by 202 because those are the row totals there. Now, one other side note before we get into doing this: when you build a conditional distribution, you just fill in the values in here. You don't worry about anything out here, down here, or the table total. You're just looking on the inside of the table here. All right, so first one would be that 21 divided by that 102, and we'll report that as a percentage. So we should get there that is 20.6%. Then 32 divided by 102, we should get 31.4%. And then finally 49 divided by 102, we should get 48.0%. Now, just make sure we understand, if you summed up these three percentages, 20.6, 31.4, and 48.0, what you would get would be 100% there, because this is telling us how the males were distributed amongst the different political affiliations. All right, let's fill in the second row. So we're going to be taking 71 and dividing by 202. So 71 divided by 202 looks like we should get 35.1%. Then 33 divided by 202, we should get 16.3%. And then 98 divided by 202, looks like we should get 48.5%. Okay, let's quickly pull out a couple of these values and just talk about what they mean here, right? So this 48.0 there, right? If we pull that out there, what that means is that 48.0% of, well, not of our sample anymore, of men, because that's how we conditioned or how we restricted. So 48.0% of males in our sample identified as other. So, in other words, 48% of males identified as some other political affiliation. All right, if we take a sort of value like this guy here, this would tell us that 35.1% of females in our sample identified as Democrats. So, as you guys can sort of see, what this conditional distribution is doing is it's restricting our attention to each gender category one at a time. So this tells us how males were sort of distributed into the political affiliation, and this tells us how females were distributed into political affiliation. In future examples, we'll do more analysis of this, but you can even see in this case what sort of conclusions we could draw. We could see that females were more likely to identify as Democrats, 35.1%, compared to males that identified at only 20.6%. Whereas males were much more likely to be Republicans, 31.4%, versus females with only 16.3%. But really, there was no difference in males or females who identified as some other political affiliation. So we could sort of conclude that females were more likely to be Democrats, males preferred to be Republican, and they both had about the same level of choosing some other political party. All right, so there's our conditional based on gender. Why is the conditional so important? Well, notice that, as we sort of mentioned here, we can sort of see that females were sort of unlikely to be Republicans, and certainly way more unlikely than males were. If you look back at the raw data, somebody might be confused by that and say, well, weren't there more female Republicans than male Republicans, 33 versus that 32? But you got to remember that 33 female Republicans were out of 202 females overall, whereas the 32 male Republicans were out of 102 males. So there were about 100 extra females, but only one extra Republican. female. So that shows why we're getting such a lower percentage here as opposed to there. All right, we did promise that we could build one other conditional distribution, so let's do that. We'll base it on the other variable. So we can do a conditional based on political affiliation. Now, this doesn't make as much sense from a practical side of things because that's not really the explanatory variable, but just to see it, that means we're going to divide by the column totals. So we're going to still go ahead and recreate our sort of diagram here, male, female, and Democrat, Republican, other. So we'll just make our nice little chart there. All right, so now we'll be using the column totals because political affiliation was in each of those different columns. So to begin with, we'll take 21 and 71 and divide by 92. So 21 divided by 92, right? That should give us 22.8%. And 71 divided by 92 should give us 77.2%. Then 32 divided by 65, so 49.2%. And 33 divided by 65, which would be 50.8%. 49 divided by 147, so 33.3%. And then 98 divided by 147, which would be 66.7%. And again, just to help understand what those sort of values mean there, right? That's 77.2% would say that 77.2% of Democrats in our sample were females. So what that's saying is if we were restricting our attention only to the Democrats in our sample, well, then 77.2% of them were females. Now, interestingly enough, right, notice that females had a higher percentage in every political affiliation. And that should make sense because there were more females by a wide margin in our sample than males. So you can sort of see how this conditional distribution here doesn't really give us a lot of useful information because basing it on political affiliation is sort of choosing the wrong explanatory variable. This one here, based on gender, really tells us more about the relationship. And we'll explore that more in our next sort of set of videos working through some examples of doing this conditional analysis. Keep in mind here, the main things that you should take away from this video, make sure you're comfortable with the two-way table, the marginal distribution, and this conditional distribution.